Okay, welcome back, you guys. Let's get going on example 6. So again, we're trying to show, are the triangles similar, and if so, which shortcut can we use? Let's remember, we have SSS similarity, we have SAS similarity, and we have AA similarity. So those are our three options. Okay, so again, when I get started, I kind of look what's given to me, and that will kind of point me in the right direction as to which similarity postulate we're going to use to show triangles are congruent. Which, if you guys see here, the only things that are given to me are side lengths. I have 3 side lengths given to me in the first one, and 3 side lengths given to me in the second triangle. So my hunch would be that I'm going to show that these triangles are similar by SSS. Now, in order to show triangles are similar by SSS similarity, I must show that all 3 sides are proportionate. Okay, so when I reduce down all 3 sides, when I reduce down their scale factors, they must all be the same number. If they're not the same number, then they're not proportionate, which means our triangles are not similar, which I hope they are, because it's really sad and depressing when they're not similar. Okay, so let's get going. So on this one, we're given 3 sides, so we're going to be finding 3 scale factors. So I'm going to go ahead and set that up since I have 3 sides. So scale factor, and scale factor. Okay, and to make things easier, I'm just going to compare the smallest sides first, then the medium length sides, and then the largest sides. So let's get going. So what are the 2 smaller sides between my 2 triangles? Holy hot dog, you guys always know the right answer. It would be the 3 and the 9. So this one's 3 over 9. Okay, which I need to reduce that down. Which, do you guys know a number that will divide into 3 and 9? Of course you do, because you always know. It would be 3. So I'm going to divide both of these by 3, which 3 divided by 3 is 1, and 9 divided by 3 is 3. Okay, so my first scale factor is 1/3, and again, how I figured this out, well, it was given to me. So the reason why is the given. Okay, so in order for this to work out, all 3 of these must have a scale factor of 1/3. If not, well, I'm just going to throw in my pen and be done, because that means they're not proportionate. But I'm not going to get my hopes, or I'm not going to give up yet, because I don't know. My hopes are still up. So let's see. Okay, so my next one, I'm going to compare my 2 middle lengths. So not the longest side, but not the shortest side. So in this one, the next longest side would be my 6. So I'm going to write 6 over my next longest side in this triangle would be 18. And again, you guys, it's really important, in this scale factor, I started with my smaller triangle and then divided by my larger. It doesn't matter which way you go. I could have divided my larger triangle, I could have divided the 9 by the 3. Just make sure you stay consistent. Okay, so if you do the larger triangle over smaller triangle, I cannot talk today. Good golly. Okay, if you did the larger triangle, goodness gracious. If you do the larger triangle over the smaller triangle, you must do that for all 3. Okay, but I chose to do the smaller triangle over the larger triangle. So on all mine, I'm going to start with my smaller triangle and then divide by my larger. Okay, sorry about that. That was a little embarrassing. Okay, let's reduce down this fraction. So a number that will divide into 6 and 18 is 6. Nice job, you guys. Okay, 6 divided by 6 is 1, and 18 divided by 6 is 3. Look at this, you guys. My scale factors are so far the same. I'm getting excited. And again, how I know this is because those values were given to me. So it was in the given. Okay, and lastly, I'm going to compare my 2 longest sides. Where are the 2 longest sides of my 2 triangles? That would be the 8 and the 24. So again, I'm going to do my smaller triangle over my larger triangle, since that's what I've done the whole time. Okay? So let's see what happens. I hope they're the same. Let's reduce down our fraction. Do you guys know a number that will divide into 8 and 24? Yeah, it would be 8. So I'm going to divide both of these by 8. Which 8 divided by 8 is 1. 24 divided by 8 is 3. I'm having a little moment right here because I'm super excited that we got the same scale factor each time. And again, this was given to me. Okay, they gave me the 8 and 24. So my reason is the given. Okay, so I have 3 sides, side, 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 and then 3 sides, side, 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 that were all proven to be proportionate because they all have the same scale factor. So guess what, you guys? My 2 triangles are similar by SSS similarity. Awesome. I'm so excited. Okay, let's write our similarity statement, then we'll be done. So triangle, let's see here, I'm going to do IHG. Why not? It really doesn't matter. Alright, and triangle IHG is similar. Now, if I trace my triangle from I to H to G, I go from 3 to 6 to 8. So from small to big, basically. So small to medium to large. Okay? So I need to go from my smallest side to my medium side to my large. So how would I write this triangle if I trace it from the smallest side to the medium side to the longest side? Yes, you guys are on a roll today. It would be J, K, L. I go from 9 to 18 to 24. So I'm pretty much going in order from my shortest side to my longest side. So J to the K to the L. And they are similar by side, side, side similarity. So SSS, and then don't forget the fancy little tilde, because that means similar, not congruent. Alright, and that's it for example 6. Example 7 will be kind of similar, but also a little bit different. So let's get going on example 7.